Hello and welcome to another video. In this video I'll show you guys how you can read and write memory using C++ and Windows API. Now I'm making this video because I got the feeling that a lot of you might have wanted an explanation how I was modifying memory during the CS2 tutorial videos. So here it is. Now in this video I'll be using Visual Studio 2019. You guys can also use whatever really you want, but it's more simple if you use Visual Studio. So let's get into it. First we're going to create a new project and we're going to select the empty template template. So you can start from scratch. And we're gonna call this trainer. I'm just gonna call it somewhere else. I guess, I don't know. Trainer tutorial. Once inside your project, we're going to have to change a few things before we actually start. First of all, I recommend you guys press on this button over here, which will show all files. Because these aren't files, these are filters, and they're automatically generated by Visual Studio, so you can organize yourself. They're kind of useless. You're not going to see them inside your file explorer once you open the repository folder. So we're just gonna press on show all files. Next, we're gonna right-click on our project, and we're gonna go to Properties. Now, first of all, we're going to change the C++ language standard. For the sake of simplicity, we're gonna change this to the previous preview features from the latest C++ working dev. So we are working with the latest version of C++. Next, we're gonna go to Advanced, and this is a crucial change and a crucial setting. We have to go to character set and we have to change it from Unicode to multi-byte. Now I'll talk about that in a second. Also make sure that your configuration is being made for the release in x64 because we are working with CS2 and CS2 is an x64 game. You're going to go to your project build configurations and set that to release in x64. And now we have to do a few more things. First of all, we are going to have to create a source file, C++ file, and we're going to call it main. This is where your entry point is going to be located at, and this is where your code is going to start at. So let's actually include a library. Let's include IOStream, so we can actually give some output at the end of the video. And now we're going to create our entry points. If you guys don't know what this is, please watch a tutorial about C++. It's going to help you a ton. Okay, next we have to create another file, and this one is going to be a type header. We're going to call this memory. Now header files should only contain declarations and not definitions. It's bad practice to write function definitions in a header file, but it's not bad if the function definitions are inside in a namespace. So we're just going to create a namespace, and I'm going to call it vars. Now, you guys can call it whatever you want. For me, it's a tradition because my first program in C++ had a namespace called vars. It stands for variables. That's just me. Next, we're going to have to include two libraries. The first one is going to be windows.h. Now, windows.h is the central hub for accessing Windows API. It comes in with Windows data types, Windows function definitions, and all kinds of stuff like that. It's very important. Next, we're going to have to include tlhelp32.h, which has function definitions and variable definitions from the toolhelp library. Now, the toolhelp library is mostly about working with processes, modules, and threads. Now we're going to create 4 functions inside our namespace over here. Now the first 2 are going to get our process ID and a specific module base address from the process. Now a process is an application running on your system, basically. So each process on your Windows has an integer value which works as an identifier of what that process is. We need to get that so we can actually find the base address and the location of where the application was allocated at when it started. so we can then actually find the addresses which we will have to write to and all kinds of stuff like that. And the first function, as I said, okay, it's going to get your process ID. It's going to be a type D word, and we're going to call it get process. For the parameters, we're gonna put in a const char pointer. We're gonna call it process name. Now, a D word stands for a double word, and it stores uninside 32-bit integers. We're using D words because process IDs are mostly nearly 100% all simple, and they're not based on the application's architecture. Now, a const char pointer is another way of writing a char string, a char array, which creates a string. So here we're just asking for a string, which is going to be our process name. Because the way we're going to get the process, we're going to get a list of all the processes running on our in our background, and we're going to filter all of their names until we find the specific one that has an equal name with the name from the parameter over here. Okay, so let's get into it. We're going to create a snapshot handle. Now, a snapshot handle is the value returned from the call of create tool help 32 snapshot. And create tool help 32 snapshot is takes snapshots of things running on your background, and by snapshots it takes basically photos. Now for the first parameter that we're going to have to give this function is going to be what we want to take a snapshot of, and there's multiple options, but in this case we're going to be taking a snapshot of processes. So th32cs underscore snap process. The second parameter is going to be a process ID. In this case, we don't have enough process ID, so we're going to put it to 0. Now this function behaves in such a way, if the second parameter is 0, it's going to take a snapshot of all the things running in the background. In this case, it's going to take a snapshot of all the processes. So yeah, that's cool. Now also, to talk a little bit about the handle, because maybe some people will get confused. What the fuck is a handle? Now a handle is a special type of data structure used to represent and manage various system resources, like files, memory, or like synchronization bullshit. Don't think too much about it. Okay, next we're gonna do some error checking. We're gonna create an if statement, and we're gonna be checking if our snapshot handle is equal with an invalid handle value. And if so, we're just going to return 0. Next, we're now going to create a variable of type process entry 32. We're going to call it process entry. We're not going to set it to anything. Now, process entry 32 is a class inside the TL help 32 library, which basically stores information about processes, basically like their name, their process ID, their size, and stuff like that. Now, there is a member inside the process entry class called DW size. Now, this represents the size of the class. Now, across multiple Windows versions, this number might be different compared to the actual size of process entry 32 in bytes. These two should be equal, but if they're not equal, it might cause like memory leaks and errors or shit like that. We don't really want that. So we're just gonna straight up set the DW size value with the size of process entry 32 in bytes, so we can maximize the compatibility of this application across multiple Windows versions. Okay. Next, we're going to create another if statement, which we're going to call it process 32 and here we're going to call process 32 first function. Now, this if statement is basically checking if we actually have a snapshot and know if we actually have a process in our snapshot. Now, inside here, when we call this function, it's first going to ask us for a snapshot handle and for a long pointer to our process entry. Now, it does this, and let's actually talk a little bit logically why we're doing this. Now, if this process entry 32 function returns a valid value, this if statement is going to be true. And if the statement is going to be true, that means that we actually have a process, a first process, inside our snapshot handle. Now it's asking us for a process ID because once we call this function, it's going to store all the information about that process inside the process entry class that we created. So yeah. Now afterwards we're going to create a do-while loop. Now do-while loop is a little bit different than a while loop, because the do-while loop works, first of all, it executes the code, the block of code that you put inside here, and then it checks this condition, the while condition. If that's true, then it repeats it. A while loop, it basically checks the condition, and if that's true, then it repeats the code under it. Now, inside our while condition, we're going to call the process 32 next function, which is going to iterate through our processes on our snapshot list. So we're first of all going to have to put a snapshot handle and our process entry. Inside the do while loop, we're going to create an if statement, which is once again going to call a function called stricmp. Now this stricmp function compares two strings. Based on the comparison result, is going to give us a simple integer value. Now this function, if two strings are equal, it's going to return the value of 0. So first we want to compare the name of our process, which we gave when we're going to call this function, and then we're going to compare the name of the processes from the snapshot list, which can be found inside the process entry .shex file. And if this is equal to 0, then that means they're equal, and we're going to close the handle, the snapshot handle, and I'll talk about that why in a second. And we are also going to return our process ID, which once again can be found inside our process entry at the member with the name of th32 process ID. Okay, now we're closing handles because when we open a handle, it's good practice to close it when you don't need it anymore. Now we're doing this because it might, if we leave open too many open handles, our program might cause memory leaks and errors and shit like that, shit that we don't want. So it's best just to close it. And we're gonna do the same thing, but we're gonna do the same thing here. Because let's say we don't actually have a process, first process inside our snapshot list, and instead of returning process ID, we're just going to return 0. And also we need to add a semicolon for our while condition. So this is the get process function. The next function is going to be the get module base address. Now we're just going to copy paste the get process function so we save some time, and now we're just going to change it. First of all, the data type of this function is going to be untptr_t. We're going to call it get module base address. We're going to be asking for a module name and a process ID. I'll talk about that in a second. We're once again creating a snapshot handle. Instead of snapping processes, we're going to be snapping modules, and also 32-bit modules. Snap module 32. I'm not sure you snap 32-bit modules, or I don't know. It's best to do both of them. And for the process ID, we're going to set it to the specific process ID from the parameters. Once again, we're doing the same shit here. Instead of using process entry 32, we're going to be using module entry 32. I'm going to call this module entry. We're doing the same thing here. And instead of process 32 first, it's module 32 first. This is once again module 32 next. And we're going to find the name of the module at the member with the name with sz module, and we're going to find the module base address, so the address of the module where it's located at the mod base address. And because mod base address is a byte pointer, we actually will have to convert this to a untptr. So we can do that by using the reinterpret cast operator, which is not that safe to use, but it's in this case it's pretty safe. You can use this, so it's good. Now we're using untptr_t for a few reasons. untptr_t can store integer values across both architectures, 32-bit and 64-bit, without losing any memory, which is good because the module base addresses are their value is based on the architecture of the actual application of the actual process. So if we're working with a 32-bit game, it's going to have a 32-bit value. If we're working with 64 game, the module base address is going to have a 64-bit value. Okay, we look pretty solid. We're done with both of the two first functions. Now next, we're going to have to create two function templates for our memread and memwrite functions. Now to create a template, we just have to write a template, create these two arrows over here. We can either put type def or type name, and here we can write whatever we want. I'm just going to put type. Now templates, they let us create functions without giving a specific data type for them. Templates, they let us decide our data types when we're actually calling the function. So that's cool. Now for the memwrite function, memread, we need to create a function with an undefined, with non-mentioned data type. We're going to be asking for, what the fuck am I doing? For the address of which we want to read information from. It's going to be a type of untptr. Now the first thing we have to create a variable with an unspecified data type. We're going to call it value. Now this is going to store our memread. It's going to store the memory is going to store the read information from this address over here. And now we're just going to call the read process memory function. It's going to ask us for, oh yeah, process handle. Now we also need the process handle over here, so yeah, I keep forgetting about that. Now process handle is, in a nutshell, is a certificate that lets you read and write, or it's a certificate that gives you a certain amount of access to manipulate a process. In this case, we're going to create a process handle which let us do whatever the fuck we want. And that's really why this method is detectable, because games can detect open handles to their own program very easily. So this is why it's detectable. First is going to ask us for a process handle. Next is going to ask us for an LPC void base address, so that's the address which we want to read information from. We're just going to typecast our untptr address to an LPC void. Next is going to ask us for a pointer to our buffer, so our variable which will have the stored red value at. Next, the end size, so that's going to be the size of the type we're going to be reading. And the last one, the number of bytes read. We do not know how many bytes we're reading, so we're going to set it to 0. Okay, and now we can just return value, which is going to give us the red value. Okay. Now I'm just gonna copy paste the memread template function, and in this case we're gonna change this to memwrite. Gonna be asking for address, process handle, and also for an unspecified type value, which is gonna be the value which we want to write the value that this address holds. What the fuck? And by the way, the memwrite is going to be of type bool. Now after do all this bullshit, we can just return the call of write process memory, which is a bool by the way, and it's going to give you a true or false based on if the write process memory was successful or not. And once again, it's going to ask us for a process handle. In this case, it's going to be the base address, so the address which we want to write its value to an LP void. So we're going to typecast that again, not an LPC void. Okay, next is going to be a pointer to our buffer, so that's the value which we want to write the value of address to. Next is going to be once again the size of the type we're writing, and where the last one is 0. Okay, now we're basically done. So now to actually test if this works, we're gonna go to our main, and we're now going to include our header file, memory.h. Now we can actually create some variables which will contain the value of our shit. So for example, process ID, let's create a process ID variable. We're going to call the getProcess function, and we're going to be searching for cs2.exe. Now let's create a process handle. How to do that? We need to call a function with the name of openProcess. For the first parameter, it's going to be the access you want to have over the specific process. So we want all access. So to process all access. Next, it's asking us if we want to inherit a handle. Fuck no. No, false. And for the process ID, which is going to be process ID of CS2. Okay, now let's also get the base address of client.dll. I'm just going to call this variable to base address. And we're going to call the get module base address function. And inside, now we're going to yeah, it's going to be client.dll. And for the process ID, once again, is the process ID of CS2. So now let's give some basic outputs. Okay, now let's open up CS2. Okay, it's open. We can minimize it. Now we are just gonna open it. And as you can see, we actually got process ID and module base address of client.dll. Okay, so it worked. Now I want to talk about one more thing. I want to talk about the reason why we actually changed our character set from Unicode to multibyte. Now we did that because really doesn't really make much. It doesn't really matter if you change it to Unicode. But if you would change it to Unicode, you would have to change you would have to change everything from normal characters to wide characters. Now we have to do that. We would have to do that because the process entry 32 class and their functions are created to work with wide characters. If you don't know what a wide character is and a normal character, see it as a character which has a greater size over the normal characters. And in C++, uh, some library-defined functions work only for some type of um, characters. Now, these ones, they only work for, they're made to work only for wide characters. So if you would change it to Unicode and keep it Unicode, we would be asking for a const vchar underscore t, and to write a wide character, a wide string, we would add an L and then yeah, and that's how you write it. And also, instead of using stricmp, we would have to be using underscore vcsicmp, which you guessed it, it works only for, it's made to work with wide character strings. And see, you can also see its parameters: const vchar, string pointer, string 1 and string 2. And this one is char. So that's the reason. That's what you would have to do if you would have to change it, if you would want to change it or keep it on Unicode. Now we changed it because I don't want to confuse people too much about this, and it's just simpler and cleaner just to write normal strings and work with normal characters. So yeah, thank you guys for watching this video. I'll see you in the next one. Take care. See you.